Okay, so good day. I am Aaron Joseph Mijares, and I'm here to summarize the midterm coverage for our subject, which is Quantitative Methods IT 224. So here's for Module 1, that's entitled as the overview of basic concepts of quantitative methods. So this module has introduced some basic terminologies and that lays the groundwork for the course. Every explanation what is about quantitative methods, its types, its tools, and importance. Moreover, quantitative methods emphasize objective analysis of data collected through polls, questionnaires, and surveys. So everything in this module is all about the definitions of everything all about quantitative methods or models. So this part describes the definition of a quantitative, which is an adjective that simply means something that can be measured. Quantitative data expressed as numbers. Quantitative data, I mean, qualitative data is a bit like a countable noun, but they both refer to things that can be counted even if it seems like it take a time to measure. And analysis is the numerical methods to ascertain size, magnitude, and amount. So everything that we have seen so far here in our module describes what are or what is quantitative methods. So next part is the what are the different types of quantitative data. So there are continuous and discrete, wherein discrete data is a count that can't be made more precise, and typically it involves integers only. So countable, and there are no other types of measurements. And the other one, which is continuous, can be used in many different kinds of hypothesis tests, or I could always say that it could be divided and reduced to finer levels, and data can be taken on any value, meaning it can be measured using a decimal point, and you could always see how precise the measure of a certain object. And what are the tools of quantitative analysis? Here we have experiments, we have controlled observations, we have surveys, we have longitudinal studies, we have polls, we have telephone interviews, we have face-to-face interviews, and etc. and etc. So next is the scales of measurements. So we have one, two, three, four. We have four types, which is described as follows, which is first one is the nominal scale that describes differences between things by assigning them to categories. So categorical scale is the nominal scale. For example, genders, hair colors, types of living accommodation, and etc. The ordinal scale is similar to nominal, but classes can be ranked. So there are rankings according to ordinal scale. You can classify them as nominal scale, but the difference is that the ordinal scale is ranked instead of being just categorical. For example, or there are high school class rankings from first, there are ninth, there are 87th. For socioeconomic status, there are people who are poor, who are in middle class, who are in the rich ones, or even using the Likert scale, using strongly disagree, disagree, neutral, agree, and strongly agree, etc. and etc. The third one is the interval scale, shows that an exact distance between two categories can be determined, but the 0 point is arbitrary. Here, ratios between every differences are known, like in temperature grades. So we could see here that it has a value of equal intervals that means something. For example, a thermometer might have intervals of 10 degrees. In each degree, for example, here in our Celsius temperatures, in Fahrenheit temperatures, IQ, SAT scores, and time on a clock with hands. So it is ratio by ratio. It is what or how we could describe interval scale. The fourth one, the ratio scale, is similar to the interval scale, but the 0 point is fixed. This considers a ratio between any two values like ages, heights, or weights. So a ratio scale has the equal interval properties of an interval scale, but has two additional features, namely, they have different things. For example, 5 grams is one half of 10 grams, 15 grams is 3 times 5 grams. The behavior sciences are generally limited to describing variables in interval scale form, a less precise type of measurement. So we could only say that the ratio scale is much more precise than the interval scale. Examples are age, weight, height, scales, figures, ruler measurements, income earned in a week, years of education, number of children. So these are types or different datas that we would tackle in this subject. I have learned more about these things as quantitative methods are needed for us to study on how we could create a thesis in the future. So here we are in our next module, which is module 2, learning about variables. So variables can represent numeric values, character strings, or memory addresses, and it plays an important role in computer programming because they enable programmers to write flexible programs. Rather than entering data directly into a program, a programmer can use variables to represent data. So basically, variables are the ones that represents data. For example, if you want to apply a specific type of measurement, you have to put a variable, meaning it represents the data so that you can use the data throughout your program. So observations are the raw materials with which research workers deal. For statistics to be applicable to these observations, they must be in the form of numbers. Statements such as Marcia is blonde or he weighs well over 200 pounds are common and informative. Since much of our discussion must be general, we employ some symbols. So everything is going to be put into symbols. So each type of statement, by using variables, we could represent them as data. Instead of numbers in our programming, we could use these variables to represent statements so that we could later discuss or differentiate each variables depending on which statement they are giving us. So we have variables that may be either quantitative or qualitative. So a quantitative variable is one for which the resulting observations can be measured because they possess a natural order or ranking. So what we have discussed earlier about types of data, the nominal, the interval, the ratio, etc., etc. Here we can see that they could be used as a natural order or ranking. Examples are heights, weights, or number of heads that appear when 10 coins are tossed. Observations on quantitative variables may be further classified as continuous or discrete, or what we have learned earlier about continuous or discrete. The second type of variable is, oh wait, this is still continuation of a quantitative variable. So a continuous variable is one for which all values in some range are possible. Height and weight are obvious examples. So height may be measured through the nearest one-fourth in inches, but this is not to say that heights exist only for one-fourth in values. We are limited by the measuring device in obtaining values of a continuous variable. So next is a discrete or discontinuous variable is one for which the possible values are not observed on a continuous scale because of the existence of gaps between possible values. Often discrete observations are integers because they arise from counting. Examples are the number of petals of a flower, what we have um, discussed earlier about discontinuous or discrete is that it is countable, meaning it is used, we could use integers by counting them or measuring them. It is a bit different from a continuous variable in which the precisement of measurements are used for you to use that specific variable. That's why they're called continuous, because the numbers are continuously imprecise to what measurement are you going to use, rather than using discrete or discontinuous that only uses integers. So next type of variable is a qualitative variable, which is one for which numerical measurement is not possible. So it is not involving numbers, it is involving quality. That's why it is named as qualitative variable. You could only describe it by things that are not measured by numbers. So, what are the two types of variables? So, we have first one, which is the independent variable, and the dependent variable, which can be affected by or changes to the independent variable. So, independent variables are things which can be controlled or manipulated. And the dependent variables, which are affected by or changes to the independent variable. So, this is how I understand this thing. Independent variable is the one that changes the outcome of the dependent variable. That is why it is called a dependent variable, because it is dependent to the independent variable. So it needs to have an independent variable for the dependent variable to change. You can think of independent and dependent variables in terms of cause and effect. It's the same as what I've described earlier. An independent variable is the variable you think this is the cause, while a dependent variable is the effect. But the one that is being changed is the dependent variable. So below are the overviews of these experiments. For first experiment, this example is you want to figure out which brand of microwave popcorn pops the most kernels so that you can get the most value for your money. It has different brands of popcorn to see which bag pops the most popcorn kernels. So the IV here is the brand of popcorn bag. It's because you are actually deciding the popcorn bag brands. Then the dependent variable is the number of kernels popped. The dependent variable, it is because of what you measure for each popcorn brand. So there are lots of examples here which I have seen, and I have learned more about IVs and DVs, which we could um, use this for later on for our research paper if we are about to make one. So for all of these things, we have groups for scores, looking at how the independent variable changes the dependent variable. Mm. So that's all for module 2, with which we could see here. So yeah. So for module 3, we have statistical methods. So these are the things that, or the procedures that are used in the collection, analysis, and interpretation of data. So these statistical methods would be divided by two, which is the descriptive statistics, and the second one is the inferential statistics, which involves estimation and hypothesis testing. So here we could see that the descriptive statistics comprises those methods concerned with collecting and describing a set of data so as to yield meaningful information. It provides information only about the collected data and in no way draws references or conclusions concerning a larger set of data. So this descriptive statistics, after you collect the data, it only describes to a certain thing or a certain topic which it describes as to prove if it is there really, or the numbers that describes the specific topic would be its truthfulness or genuineness. Meanwhile, in inferential statistics, we could see that it needs some estimations and hypothesis testings. So among the different descriptive tools for descriptive statistics are the percentage and frequency distributions, ratios and ranking, measures of central tendency, measures of variability, statistics of association, and tables and graphs. And note that the construction of tables, charts, graphs, and other relevant computations in various newspapers and magazines usually fall in this area. So here we can see the example of descriptive statistics wherein it describes the mean, the range of each intervals, and the proportion. So these results indicate that the mean score of this class, etc., etc., wherein we could see that the data gives the students the result gives us that the students have acceptable scores of 86.7% out of 70 students. So next is the inferential statistics. Statistics inference comprises those methods concerned with the analysis of a subset of data, leading to the predictions or inferences about the entire set of data. These statistics takes data from a sample and makes inferences about the larger population from which a sample was drawn. Because the goal of inferential statistics is to draw conclusions from a sample and generalize them to a population, we need to have confidence that our sample accurately reflect the population. This requirement affects our process. So in each thing that inferential statistics gets, it describes on how genuine or how true a specific thing or we are curious about to which it is getting described. So we have here the steps. So first is the define the population, draw a perspective sample from the population, and use analysis that incorporate the sampling error. So using a different sample or random sample, we can generalize from the sample to the broader population. Unfortunately, gathering a truly random sample can be a complicated process. So there are hypothesis tests concerning in inferential statistics, there are confidence intervals and regression analysis. So here we could see the functions of statistics, both descriptive and inferential, wherein in descriptive statistics we could see that we need to have these central tendency, variability, shape, and correlation, even prediction. While in the inferential one, we need even the generalizing of a specific population according to what we have seen or what we need to look up using estimation and hypothesis testing. So the final module for our midterm modules would be the measures of central tendency and skewness, wherein we could see it from the descriptive statistics. We need these things and we need to discuss this. We need to understand each term. So here we are, descriptive measures, centrality. Measures of central location wherein we could see the mode, the median, the arithmetic mean. The mode is perhaps the simplest of all averages, simple in both concept and computation. We could only see the mode when there's a number in which it has the most repetitive number. So for example, here we have 2, 2, 4, 4, 4, 7, 9, 9, 9, 9, 9, 12, 12, 13. The mode is 9 because it has 4 numbers. It is not 4 because there's only 3. It is not 12 but there's only 2. And 2's only have 2 numbers indicated. This is a central tendency for those nominal level data, which means it's only integers, not involving those numbers with decimal places or continuous data. So the next is the median, which is defined as that point in the distribution that divides an ordered set of scores into two equal parts so that one half of the score fall above and one half below it. So the median is the number with which you could only see in a nominal data. It's the center part of your data. Here we have an example So 2, 5, 7, 8, 11, 14, 18, 21, 22, 25, 29. So we have 2, 4, 6, 8, 10, 11. So we have 11 numbers. The sixth number, which divides 5 on the left and 5 on the right, is the median, which is 14. If the number of your nominal data would be a mean number, so there's two possible numbers that are in the middle or in median. So we have to add those two and divide them by 2 so that you could get the median. The next is the arithmetic mean, which is the average that most of us think of when we hear the word average. Mean can be determined only for data that are at least at the interval level of measurement, since it takes into account the value or magnitude of each score that enters in the computation. So the concept of mean is very important to more advanced discussions of measurement and sampling, because there are lots of groups wherein you have your population or random population. There are two different types of means there, so we have to distinguish them. So each of the averages we are referring to here as a unique meaning that is different from that of the other averages, that each represents a different aspect of the data. For we have here, taking for instance the following illustration for table 1, wherein this is a family income in X city. Suppose that a certain community was being described by three different persons. In describing the community's financial well-being, the representative of a certain club states that the X city is a thriving, healthy financial community, why its average family income is 23,200. I mean, there are 13 families, and then you have the numbers. So, describing the same town, all these three people are speaking about the same city in the same year, and their calculations are based on the same factual information and are accurate. All are telling the truth, but not the whole truth. They are all telling the truth because the term average has multiple meanings. All are telling less than the whole truth because they do not specify which average they are using when they report their data. So, what I've said earlier about the population and the group data, they are both distinguished and they have both different meanings about the mean or the average. So, next, the effect of extreme scores using skewness. So since the mean depends on the value of each and every score in a distribution, it is strongly influenced by extreme scores. Consider the following distribution of 9 scores, wherein we have 4, 5, 5, 6, 6, 6, 7, 7, 89. The values of centrality are as follows. So we have the mode, which is 6 because 6, there's 3 of them. The median is 6 because 6 is in the middle part. And the mean is 15, wherein you add all the numbers and divide them by 9. The mean here is not a representative value because it has been greatly influenced by the single extreme score of 89 because it has a great amount of number. A score that does not seem to be typical of the usual score in the distribution. From this example, we can see that when extreme scores are present, the mean may not be an appropriate measure of central tendency. So we have to use skewness. So depending on the degree of skewness, that is the extent to which the distribution is not symmetric, the mean or may not be the appropriate measure of centrality. So we have here the normal distribution wherein the median is equals to the mode, which represents our example earlier. Positively skewed distribution wherein the mode is a bit less than the median. The negatively skewed distribution where we could see that the mean is in the left of the median and the mode is on the right side of the median. So systematic bimodal distribution wherein we could see that the mode and the median are equal side by side. So they are either positive and negative. So there are other different distributions in the fifth column. So with many instances in which a comparison of the same average over two distribution may be misleading. So these are the things wherein we could see the examples of frequency distribution, and we could see how we could understand or tally the interval midpoints, the frequency, the relative frequency, cumulative frequency, and cumulative relative frequency. So these are the next are the practices wherein we could see or we could calculate using a scientific calculator the standard deviation or even the mean of our sample data. Then we have done that using a scientific calculator and all these things, even the sample computation on ranked data, especially on looking at the total weighted scale of or weighted score of each by using Likert scale of the strongly agree, neutral, disagree, strongly disagree, etc. and etc. Or even the ranking in accordance to what or how we could use a sample distribution in accumulating data. So everything in module 4 is discussed all about um, the measures of central tendency and skewness, and the most important part is how you could take the central tendencies of each data that you could get. So that's all for I have for everything in our midterm coverage for quantitative methods subject IT 224. This is Aaron Mijares, BS IT 2B, and see you on